Ladies and gentlemen, I'm glad to introduce our next speaker, Daniel Riek, talking about how complexity on clouds and the software stack impacts the freedoms of GNU. Welcome.
Thank you very much. See if you can hear me. Can everyone hear me? Awesome. It's a great honor to be here at FOSDEM. I've been at FOSDEM a lot. I've never spoken, and this is slightly intimidating, so I hope you bear with me and don't throw anything at me. My name is Daniel Riek. I've been in GNU Linux for quite some time. Started a Linux startup back in the 90s in Germany, moved to Red Hat eventually, and I spent a lot of time on figuring out things like software packaging distribution. I was a product manager for Red Hat Enterprise Linux for a good part of my career. I was involved in driving the container transformation at Red Hat towards Docker and then later Podman and OpenShift. Right now I'm in the CTO office working on open source AI, which I'm not talking about, but maybe next time after the last talk I'm really intrigued. That would be an interesting topic as well. Disclaimer, I work for Red Hat. I will use the Red Hat stack as an example. Nothing I say is specific to Red Hat, and nothing I say can be misconstrued in the official position of any of my former, current, or future employers. It's just me. Red Hat is now part of IBM. We're a subsidiary, which is kind of ironic because IBM originally got me into free software. It's an anecdote. I was a kid. I was using OS2 at the time. I had to do a programming project for school. And Turbo C didn't work anymore on OS2, what I had been using on DOS before. And my father was riding the train to work with someone from IBM. So he asked, can my son get some software development tools for OS2? I said, yeah, sure, tell me what he wants. So I gave them a list, and they came back, yeah, that's about $20,000 worth of software licenses. Yeah, I didn't get them. And instead, I started using GCC in the port by which is the OS2 port, DJ did that, right? So, who also works at Red Hat. It's just kind of funny. And IBM now. Right? So that's how I got to free software. And since I've been in this space, you'll find that I'm a little bit opinionated at times. And my clicker just gave up. Awesome. It's just slow. Okay, so the title, Greybeard, I count myself in that category now, right? Greybeard fight Balrogs, they hate systemd and they fork distributions. Right? This was started by a well-known debate around systemd, and my claim is that this is going to be worse than systemd. Well, I'll just use this one. So what's the traditional role of the GNU Linux operating system, right? You can have a lot of these debates. One view is you look at it from an infrastructure up point, right? It's a kernel that lights up hardware, makes things boot, you enable that, right? And that's a strong view that many GNU Linux developers hold, right? We often have a very kernel-centric and low-level view on things. But the other view is that you look at it from the application down, right? What the user space does, glibc and then everything above that, gives you an application interface, right? The kernel with the syscalls, obviously, as well, gives you an application interface that again makes an application run on hardware without having to change because of small changes in the hardware. Sure, if you have a different hardware architecture, then there's change, but in general, if there are minor changes, you don't have to change your application. And that's how GNU Linux has become the predominant binary abstraction layer for cloud, right? Today, you compile a binary and you run it in any of the clouds in a VM or on bare metal, and you don't have to change the binary, right? So it's an application interface. And it's really important to have both views, right? The role is really to bring the two together, let applications run on hardware. A general theme we are seeing is that software stacks are growing in complexity. Right? I found this on the internet, so it must be true. Well, the general trend definitely is true. We can all observe that. That crazy line is NPM. That might all be forks of the same project for all I know, but still, people, developers nowadays use software, from all kinds of sources, and stacks get more and more complex. That's changing how we look at things, right? Because you have to keep up with that if you want to keep your developers happy. Historically, what we've done with GNU Linux is that we commoditize the access to software and the choice of hardware. Right? If you go back, I'm skipping mini computers, which like are just small mainframes, if you ask me. So mainframes, right? This was a model where you had a very vertically integrated proprietary approach. You had hardware that often you leased, right? You didn't necessarily even own the hardware. You had a controlled operating system and a very controlled ISV ecosystem, right? Often the vendor of the mainframe could control what software you could deploy, right? So basically closed black box applications on a closed platform, often leased hardware. We had UNIX and open systems, things like that in enterprise software, where you had very controlled, in most cases, very controlled hardware and operating system environment, right, with controls of which tool chains you get, often with certification problems or even controlled environments on who can get the tool chain to put software on top, right? That depended by vendor, but at the end it was still a very, very confined model where your choice of what you could do was very limited. At a minimum, you couldn't choose hardware freely. Right? In most cases, you had constraints around the software ecosystem, and that's where GNU came in. Right? When I was dealing with that kind of stuff in university, many people would, by standard, install the GNU tools on their proprietary Unix to liberate it to some degree, at least. Right? Now, with what Linux, and I'm using Red Hat Enterprise Linux as an example because I worked there and I was a product manager, right? So intimate knowledge, but that's true for Linux in general. What Linux did, Linux took away those control points, right? One funny way to say it is that we allowed people who could only afford PC servers to run their IT like they could afford Sun servers. But in reality, what it did, it opened the ecosystem, allowing you to choose from any kind of ISV. Any ISV could have access to all the tool chain. It's a fully modular system, right? You can pick and choose at any level, and you could run it on any hardware you like, right? And if the hardware you want isn't supported, you can contribute to any layer of the stack and make your hardware work, right? That's a fundamental change and completely democratizes access to software. And that is what free software did. Now, how did we manage this stack back then, right? I talked about software complexity. Back then, it was already fairly complex, right? I got to GNU Linux through Slackware, which was a distribution that basically had precompiled tar, precompiled binaries packaged in tar with an installer that actually enabled me to bootstrap a system, right? And then you would go in and you would start compiling things in user local, right? Because the distribution didn't have everything you wanted, or not the version or whatever. And then you used something like stow to create symbolic links into your user bin tree or in user local bin and things like that. What we did back then, and I remember that feature request actually for RHEL, we actually created binary repositories that we mounted via NFS, from one central machine where we built it to run on the individual machines, right? And that was all trying to deal with scale, right? Like if you had big multi-user Sun servers, it was fine to treat them as a pet, right? You had multiple admins per server. Then we started with a Linux-based PC server. Suddenly you had multiple servers per admin. And you needed to somehow deal with the complexity. And the problem is that the state of the machine, the state of the software stack on the machine defines the behavior of the software you compile on it. Right? So reproducibility was a real problem, and it just didn't scale. It was really like a source level late binding we did. And if anyone ever dealt with things like automake and so on and wondered why, right? That's why, because you had to compile software based on different environments you found. The next innovation in software packaging was pre-built binary packaging, right? So I said Slackware had tar files, but they were not really good, right? They didn't know much about the life cycle of an application. You just untar it. It was pre-built, but it didn't really manage dependencies well. It was a pain, right? And it wasn't consistent. But things like RPM or Debian packaging came in, and they changed how we consume open source software, right? Instead of having something that just bootstraps and we compile ourselves, we moved to a model where things usually are pre-compiled. And remember, there was a time where like everyone would install a Linux distribution and you would go in and compile your own kernel, right? There was a time when the kernel still could be compiled in a day on a regular machine. Over time, these kind of habits moved away, right? Nowadays, modules helped, of course, but so there was technology progress and change in what people focus on, how they consume this. And ultimately, we had this massive standardization on a few number of distributions with their pre-built binaries that people use. Now, that comes at a cost, right? Both RPM and Debian packaging implicitly move you to one version per namespace or monolithic user space. There's one version of everything installed at one time by default. There are workarounds with relocated packages and so on, but they're painful, right? So back in the day with user local, you could have your own version of some tool, right? If you like Emacs, right, you could have your own version of Emacs, right? And you could have multiple of them, and you could consume them on the same machine. We now move to a model where, by default, you have one version of everything unless you go through hoops or the distributor goes through hoops to provide relocation. And that really changed how we use these machines. Right? It's a big fundamental change. And for example, like a long debate we had at Red Hat is like we had a Java department, right? And Java is like this abstraction layer, in a way their own it's a virtual machine, right, on top of something. And we always said, you have to package this as RPMs. I said, no, we don't. I had to leave Red Hat and come back to understand why, because I was so in the Linux monolithic user space, standardized everything model there, I didn't understand that those people actually wanted every software in their home directory, right? And each user had their own version of something because they optimized from the application down. It was a perspective, right? I looked at it from the bottoms up, they looked at it from the top down, and they wondered, wow, my application works with this version of JBoss, right? And I don't want to change that version of JBoss just because someone in product management at Red Hat decides that you need to run a new version. Right? So there was this inherent conflict that we had where the one version per machine just didn't fly anymore. Right? The problem, right? The problem of scale. We moved from like one big service, multiple admins, to more and more servers per admin, replication, more and more servers being used by users, right? Sprawl of IT, and the problem we have, one problem is dependency hell, right? And if you have ever tried to install something from PyPy on a Linux machine, you know what I mean. You probably spend as much time finding out what the native dependencies are that you need in which version as you spend like working on the Python code. I'm exaggerating a little bit, but it's a big problem, right? And we have conflicts in versions. It's hard work to keep everything compatible at the same time. That's the assertion that the distribution gives you, but they can't keep up with the complexity of these stacks. You cannot package everything out of these millions of software packages that I showed in the earlier chart. And so the other problem is just scale, just number of machines you have to deal with. So we had tools, we developed tools that deal with that, right? You had automated installation, you had configuration management like CF engine, and later re-implementations like Puppet and things like that. And Ansible. So different concepts. There's a whole fight of concepts around like whether it's declarative or directive and whatever. But like that solved all the scale problem in how many machines you can manage. And you can manage huge numbers of machines. But it doesn't solve that the software stack complexity is holding you back, right? So we got a little bit of freedom in that space with virtual machines. And the problem, virtual machines basically emulating hardware liberate you from having to use a machine for exactly one thing, right? Which was a Windows problem to begin with, right? You couldn't install multiple things on one Windows server, so I had to use virtual machines to use hardware for multiple things. In GNU Linux, we didn't have that problem per se, right? It was totally safe to run multiple services. We have a huge amount how to do that. The problem we have is dependency complexity, right? If you go far enough in your software stack, you create enough dependency on some of your applications, changes in the underlying software stack become problematic, right? Because they have cross effects. And like I remember that like even though a lot of work went into maintaining ABI stability in an enterprise software distribution, there's always something you break, right? And if it's only because someone uses an interface they're not supposed to be using, you didn't know they were using it, right? And you didn't pay attention, ABI breakage, something breaks. And our operational model up to this point is actually like fairly crazy, right? We have this idea that we can deploy a machine in production, and then in production, right? So we test something somewhere, right? Then we deploy it in production, which we do by basically forgetting everything we did and recreating the machine on a component level from all the RPM or Debian packages and what else you're putting into that from scratch, right? So you don't actually test the same thing you're putting into production, because you're recreating it from a dependency tree that in itself is volatile, right? The problem is that depending how long your testing takes, the cycle between, if you have a fairly complex stack, between your testing and you moving into production, you probably have seen some security update. You go back and retest that, right? Like it gets fairly complex. And then we run this in production, and we think that at any given time we can update a random component, and it will just keep running, right? Which, like, it worked for a long time, but with the complexity, it gets harder and harder. And like, if any of you, like, if you want to try that out, just run Firefox on your laptop, right? And then do a get update or DNF upgrade underneath while it's running, and see what happens. It can be actually funny because like some underlying library gets changed, and when it loads the dynamic library in the new version, you have unpredicted behavior, right? And there is no standard way of dealing with that in the existing packaging system, right? They don't have a standard way of telling an application, oh, we just pulled the rug out under you, put a new one in, it has a different color and higher, like, there's a step now in there. We also changed the flooring. Please restart. No, we can't do that, right? So there's a problem. VM started to help with that because they gave you smaller units, right? You weren't bound to a piece of hardware anymore. The problem with that is they are pretty like obscure in themselves. They're machines, right? They're virtualized hardware, so you have to manage them as individual things. In theory, you could create a model there where you create images, and then you rebuild images, and you deploy images, you update images. At the end, no one did that, right? There's a lot of deployment as image, but then a virtual machine always becomes a pet, right? So the idea of like, oh, I have reproducibility across my instances didn't really take off. We call that VM sprawl. There's a lot of inconsistency, and management is expensive because they're so complex and self-confined. You can't easily look into them from the host. There are a lot of there's a lot of problems in the life cycle, right? I said in theory you could create an image and hand that over to another one, and then you have organizational structure and delegation, right? Someone IT defines a golden image, and then you go in and give it to a line of business application owner. and they, in theory, just install their user space application. Well, in reality, what most people do is they give them the root password to the VM, which means they have no, like IT, when they get it back, have no idea what's actually in the VM, right? Things like that. So you start virus scanning them, and it's a total mess, because in reality, right, the concept, it's too heavyweight, and it doesn't go far enough. Now, after enterprise virtualization, which becomes a predominant operational model for IT in data centers, like I would say by the end of the 2010s, by the end of the 2000s, right? And by 2015, right, like I think it's 97% of data centers are virtualized or something like that. I just made up that number, but you know, it's a huge number. That's the point. So, you know, there was another, like, the next trend was cloud, right? Like, and infrastructure as a service cloud. So what data centers with virtualization are much more flexible than the data center, where you have to order hardware and connect it to do things, right? You can share hardware, but cloud, you know, and Amazon came up with this idea, AWS, that, you know, basically took the concept of server hosting, was used for web servers, right? We had that for a long time, but moved that into core IT, right? And they started a little bit out with, it's called Amazon Web Services, right? Even though that's really not the primary use case anymore. But they created this idea that you can basically, instead of doing a CapEx model, like a capital expense model of buying hardware, you can just rent hardware from them. They manage the infrastructure, and you get virtual machine storage, so compute, storage, and networking, and they take care of that. They basically took the virtualization model and moved it to scale. They also improved a lot on the image-based workflow, even though there's still a lot of pets going on, but they automated a lot around that. It doesn't fundamentally change how you do things compared to virtual machines in the traditional sense, but it gives you elasticity, and it gives you a cost efficiency where you can scale your cost with your actual use, right? So you get rid of hardware. That's ultimately what it did. Now, along that path, we had a bigger change of paradigms, which, you know, it's hard to actually separate the impact of free software, cloud, and other cultural changes, and, you know, software eating the world, as I would say. I kind of hate that term, but, you know, on the other hand, it's also very, very right. Everything we do is software nowadays, right? Like, you know, a bunch of examples. We're putting software into our bodies, right? You know, there was an example that Steph had about somebody who has what is called a pacemaker that is software driven, right? Obviously. Right? So you put software everywhere. So software, everything, every product depends on software. Somewhere, every business depends on software. And it changed kind of who has power, right? Traditionally, the IT department could standardize things. Now the IT department cannot standardize things because the line of business and their business objective will override any IT decision. You know, at the same time, we had more aggregation of services. We had open source free software becoming the default. Winning, you know, every software stack that's eating the world is in some way based on free software nowadays. I don't think you can find any, in the general modern IT, you probably can't find any pure proprietary software stack anymore. You would be hard pressed to do that. The cloud itself is based on free software, right? It's purely free software technology at the base. You could call it a GNU Linux distribution as a service if you want to. And we have a change in behaviors driven by that in things like DevOps, agility, right? The way we do software. The key point here is that the liberation with free software liberated the developers in the line of business to do whatever they want, picking from this huge, complex set of software, right? And then that had to be managed. So the modern cloud changed, right, from the infrastructure as a service cloud. So, you know, back then we defined cloud as like, oh, it's elasticity and VMs, right? Today the cloud is actually an operational paradigm that's based on elasticity. It means you can scale up and down and your costs correlate to that. Developer velocity through service abstraction, integration, availability, right? Which means that a developer never has to stop. They can just keep going and pick services. Right? And encapsulated operational excellence. what that means is, right, in the traditional software model, whether that's proprietary or free, and when I do a Linux distribution, I give it to you, I guarantee that I build this stuff from the source code I know, that I tested these things together, and to some degree that I will provide updates to it when there's a security issue. However, it's your problem to figure out how to deploy it, figure out the architecture of the deployment, and then maintain it and manage the lifecycle. Yeah. If you take a modern stack that has multiple services, right, that's actually pretty hard. So you need an expert. If you have a modern application, you need an expert in web scale, you need a performance expert, you need an expert in databases, you need a storage expert, and you need a network expert, right? Just like to get going, right? And then you want them, of course, 24-hour, like it goes crazy. Now, if you go to the modern cloud, you press a button and you get a database. And as long as you are within the 80% of like what everyone does with a database, you don't need to do anything. Your developer needs to know how to do a data model and to talk to the API, but you're just talking to an API and someone else is maintaining that operationally for you. So what the modern cloud does is it operationalizes software, right? And it changed how people see software. Right? While free software democratized access to software, now they're taking free software and they're operationalizing it as a service for other people so that the line of business can focus on their core business. They can always go deep on whatever component is differentiating for them, but ultimately you don't have to be an expert in anything other than things you really care about, right? And that comes with a certain amount of problematic behavior, right? They use free software, they're not contributing back to the same degree. There's this concept of strip mining, right? You go into the cloud as a startup, free or none, right? Doesn't matter. You have an idea. When it's successful, they will create a competing service with their velocity and just take over your business. It's a well-known problem right now that actually has led to a deeper problem for free software where certain companies that were free software companies changed into an open core model, right, to try to defend with that. It's futile from my point of view, the open core approach. Not defending is not futile, but the open core approach is futile, but that's a different discussion. So there is this like problem where this operational paradigm, which is really useful for end users, right? It liberates the line of business, it liberates anyone from from having to carry the burden of complexity outside the spaces they really care about. But it's dominated by proprietary, vertically integrated clouds that even have problematic behavior towards open source and free software, right? On top of that, I said their core business is not access to software. That's already solved, right? Their core business is operationalizing software so that an average person can use the software, which is too complex at scale. There are just not enough experts available. So they're aggregating a lot of operational excellence, right? I'm using a little bit an extreme picture here, but that's actually true. We're at a point where in some areas there are not many companies left who can actually securely operate software, right? I've run into that problem that, I'll be honest, like I gave up running my own mail server because I just don't, like the time available against the risk factors, I just can't keep up with it, right? And this is pretty close to like what I do for a living, right? So just conceptually, like the average company or the average individual, even worse, cannot even operate software securely on their own anymore, to a large degree because of the complexity of these software stacks. You can do a simpler stack, but then you're not competitive to your direct competitors. Or you can try to outsource it to the cloud. So it really, from access to software, the problem moved to operational capability, right? And that comes at a high cost. I mentioned, it's vertical lock-in, right? You have data gravity, right? You put data in, it's really hard to get out. It's really aggregation, and if you look at it, like it has moved us forward, but we are back into a situation similar to where we started with mainframe and vertically integrated UNIX systems, right, in practice. if you go beyond the legal situation for practical consumption. So what's the alternative? What can we do, right? I think what we are doing today with packaging in Linux distributions is not sufficient anymore. Right? We have to move beyond that because we have to somehow get to a better way to manage the complexity, get out of dependency hell, and manage the operational aspects. Right? We have to basically get to the service abstraction, get the application portability across these things, and get to the operational excellence. And just as a proof, right? This is just I threw that in after the AI talk. So that's just the AI stack that my team is running inside Red Hat, right? So just a random collection of free software components that, if you want to do real open source or real AI work, data science work, from ingesting your data to cleaning your data, training your models, operationalizing that, and then retraining your models, right? You need something like this at the end. And that's really a pretty steep hurdle to just do on your own, right? Somehow we have to make that easier. And not only from a packaging point of view, right? And the traditional distribution is challenged because of the complexity, right? We cannot package everything. We cannot make everything work together in a monolithic user space. Most developers today go to native packaging, right? There's some attempts, like for example for Python, right? We have PyPy with native packaging in PyPy. So you do something, you do the lower levels of your user space in RPM or Debian, right? And then you create a virtual environment of some kind with virtenv or maybe pipenv, and then you basically do everything else in there, and you have conflicts and dependencies between the two because they are native native code dependencies in your Python packages, and they're not always wheels pre-built for everything you need, and so you deal with that. There are other concepts like Conda, for example, is trying to create a distribution, a user space distribution on top of that exists across different underlying user spaces, which creates its own set of problems because then they pick their own GCC and their own lib standard C++ and become ABI incompatible with the underlying operating systems, things like that, right? Complexity is just painful in that, and it's becoming too volatile. Updating all of that in runtime at the granular level is too complex. So what do? Well, containers luckily came around, right? Which give you the separation of the application user space from the host, right? Basically, so containers are, probably most of you know that, they're not magic, they're just a bunch of kernel features, right? Namespaces, C groups, and in some cases SE Linux, in the Red Hat cases SE Linux for security isolation. And that gives you basically the ability to run an independent user space, somewhat independent user space for your application, and you don't have a monolithic user space anymore. So you switch, it's change root on steroids, technically, but it's really useful. And if you want to try that out, I don't know if that's in Debian yet, Toolbox, there should be, but that would be awesome. But the Toolbox container in Fedora is a great example how that actually is practical, even for interactive work, right? You create that, and it creates a separate environment in which you can install tools in an unprivileged mode without touching your host, right? Really useful for development work. And the difference to VMs is that they're lightweight, right? They don't include the kernel, they don't necessarily include their own networking, right? They are just what you need, if you do it right in containers, just what you need for your application. And they have a layering model that can be reused. The layers get reused, so you have some level of space operation, right? A VM always uses full memory, and well, there's some crazy things you can do for page sharing, but containers by default reuse memory if they are built from the same underlying layer. So it's a highly efficient way, much more lightweight, and the OCI containers that came out of Docker, the Docker project. OCI is a standard, the Open Container Initiative. They also include, and that's critical, they include the pull-push model, so the publishing and the transport model for these things, which ultimately is what helped move past the problem that we had with VMs, where we never moved beyond the pet model, right? With containers, you can run them as a pet, right? And if you do this toolbox thing I mentioned, you will probably run a pet, which means you have a container that you customize for your specific work. But in most cases, what you do is you separate building and testing and operation in a lifecycle model, ties that into your CI model, and the thing you are building, testing, and operationalizing is exactly the same binary. Right? And like one way to look at containers they are a fancy emulation of static binaries on top of a dynamic stack. Right? That's really what they do. So you move from the late binding model where dependencies get resolved when you deploy in production and get re-resolved when you update in production to a model where your dependencies get hard bound before you test. And you create automation around that to make that move seamless and fast. At the end, it gives you better quality. It separates different applications from most of the cross effects of dependency things, right? So it's not, your web server won't break because your database got updated, right? And some dependency got updated because you're in separate namespaces. It also moves, like when you create, so there's a lot of containers. Most of the containers you're going to deal with, you're going to create somehow yourself when you're a user of IT. However, a lot of the components and prepackaged services you will get from a vendor, right? And it creates a separation between kind of what I call download to build, like things that you build into your own applications in your own containers, either on a package or on a source code level, and things that are prepackaged services that become easy to consume. You just deploy your database, and it's basically everything from the kernel interface up to the database. And that means that a lot of the burden of operationalizing and validating that it works is moved from the end user to the vendor, right? We've seen that at Red Hat, right? It was actually pretty hard move, right? Our QE concept used to be, you have all these RPMs, and then we change one, and then we retest that RPM, right? With containers, we pre-build containers for services we ship and the underlying infrastructure, and now we moved the full stack validation into our QE, which improves quality because now we are always retesting whenever anything is changed. So for our customers, things that at the end we left them to figure out now moved into our internal QE by just changing the model inherently. And that will make your life easier if you consume pre-built containers because it moves a very complex interface, all these dependencies between binaries, into a fairly simple container to kernel interface, which is fairly stable but can have issues, of course, so you still need to test that one. Beyond containers, of course, most applications are not just one container. Containers just a binary. You can do multi-service containers, right? You can install systemd in a container or another init system, and then run multiple services inside your container. You want to limit that. It depends what you're doing, but in most cases, you would have basically one service per container, to limit interactivity. So in a container, with anything that's in the linker dependency trees in one container, if it's just an API dependency, you put it in a separate container and you orchestrate them together, right? So in reality, most are multi-container applications, most applications, and that's where the next interesting challenge comes in, right? How do you orchestrate them together? Now the answer is Kubernetes, from my point of view. Right, and so Kubernetes. Look at Kubernetes as it's two things. It's a cluster manager, right? It implements the concept of the cluster as a computer, and it's an application definition language and orchestrator. Right. So what it does, among other things, but it clusters your machine and manages scheduling of services across machines, but it also defines the dependencies between the individual containers and how to put them together in an application and make sure that, for example, all services are running, that they get brought up in the right direction. So it's kind of, a simplified version is kind of a clustered systemd. Right? The interesting piece here is that if you put this back into the cloud concept, right, it allows you to have portability for the full application. Right? You build your application as containers, which gives them within certain constraints, portability independent of the underlying kernel version and the host, isolates them from the host, doesn't make them depend on what's on the host. You have an application definition in Kubernetes, and it itself is independent of the underlying fabric, right? You define an abstraction. So the same application definition with exactly the same binary containers can run independent of where you're running them, right? You can take them to a public cloud, you can take them to a private cloud, you can run them on bare metal, you don't have to change your application. So it's basically taking what Linux does for a single binary, takes that to the more complex stacks, liberates you from dependency hell, and gives you the abstraction model to describe a multi-service application. That's really what Kubernetes does here. And you get of course, anyway, we call technically it's a meta system D. Some people call it a meta kernel because it is it's easier for people to consume. It's of course not true, right? It's not a kernel. You get into some of the same discussions you have with Linux distributions, right, where people, I want exactly the same behavior from every implementation of Kubernetes, right, upstream distribution, versus, we have diversity in the implementation and competition, and they're not necessarily compatible, which is what we have between Linux distributions, right? You cannot take a binary from Fedora and run it on Debian and expect it to always work, right? Sometimes it works, sometimes it won't. Most of the time it probably won't, just because things are named differently. I think that's a good thing. But that's a debate that's raging right now, and you can follow me on Twitter, and I'm in a debate about that right now. So the next problem, and I harped on that earlier, is the whole operational model, right? Kubernetes itself doesn't solve that, right? It solves containers solve stack complexity. Kubernetes solves orchestrating an application and having the broader concept of a multi-service application be something you can describe and port. But now we need something that manages the life cycle, right? It's a simple problem, right? Your database needs to be installed, right? And probably the first time you want to init it. And we had ways to do that. We can do that in container with scripting, but that's like very static. You want a more dynamic way. Then you need it to be updated. That gets a bit harder. You want it to be backed up, right? And one problem that always drove me crazy is that in GNU, we never really solved that problem in a standard way, like backup, right? If you know Windows, right, you're running Microsoft SQL on Windows on VMware, right? You press a button in VMware, it goes to Windows, calls a service called VSS, a volume shadow service, says you're going to be snapshotted. Then that goes to Microsoft SQL and says, you're going to be snapshotted. Flush your buffers, go save, stop. They take a snapshot. They say, I'm ready. They take a snapshot and then restarts, and it's just one button. As soon as you introduce Linux in any of that, that goes away, and you're installing agent as a root that have custom scripts for the application you're doing. So we don't have a standard facility for managing things like that. Operators promise to solve that. So an operator is an active component that represents the runtime logic for your application. And it implements 5 levels. It implements install, deployment, upgrades, lifecycle management, including backups, then operational insights, and then ultimately level 5 would be an autopilot. And the promise here is, so the idea is that we take free software beyond access to the software, beyond packaging, and move into operational excellence. And we encapsulate the operational excellence with the application, right? Which is the only way you can really make that scale, right? The idea is that you have an external management system that knows how to run every application didn't scale, it didn't work. And we tried that too, like everyone tried that. These universes of config scripts, right, they break too much. The only way to do that is if you bundle the operational knowledge with the application, maintained by the people who really understand the application, and then deploy it through a consistent model into a controlled runtime environment. And it's the last thing that the combination of operators and Kubernetes give you, right? They give you a controlled runtime environment with a standard set of levers you can hit, and a way to encapsulate the knowledge in that so that you get to a similar model like what I described earlier. If you go to a public cloud, you press a button, you get a database. As long as you're in the 80% use case, you don't have to know anything about the database. We can get to the same thing. So if there's a vendor called CrunchyDB who is based on Postgres, and I'm not going to go into details how much they're open source, I actually don't know, but it's an example just of someone who created an operator, and they're progressing in creating the logic to manage standard database behavior for the 80% use case on a cluster, so that you can consume the software in any way you want, wherever you want, on any footprint, and still get that level of encapsulated operational excellence that otherwise you can only get from the public cloud. And that's how we enable everyone to really run their software themselves, beyond the pure access and security. There is a project, it's operatorhub.io, where you can find a lot of operators. They work on general Kubernetes. And basically that changes the platform into a new concept, right? It's the app-centric platform, I call it, right? Where you have this additional cluster model, and you basically split the GNU Linux model into a host layer that brings up the hardware, an application layer that's inside the container and is your binary runtime, like it always was, and then an orchestration around it that brings all of this together and makes it scale out and operationalizes it. And that's what Kubernetes does for you. So my conclusions, it's a little bit text heavy. I'm an artist, as you can see in my slides. Right, so Linux continues to be relevant, right? And the historic role of democratizing access, Linux is a leading example of free software that democratizes access to technology, enables you to do things that otherwise you couldn't do, right? I couldn't afford the IBM compiler stack on OS2, right? And when I got my hands on Slackware in 94, that went away and I solved my problem, right? The cloud changes what people see and how people consume software. And cloud is in a way, it's a symptom of the complexity and line of all these trends. But we have to keep up with that, right? The downside of cloud is the concentration, the strip mining, the concentration of knowledge, right? It's a simple problem of available capability in the market. And we think that containers and Kubernetes are the alternative for that. Right, that enable us with things like operators to provide, to democratize the cloud concept. It also enables, like Linux did, right? It continues the track of enabling an open ecosystem on your choice of hardware. And we need to take free and open source software beyond software access, beyond packaging, beyond making the code available, to operational excellence. 2 talks I'd like to recommend. One, the first one is just because it's my team doing it, Doth. It goes into software complexity. Frida Proconi is going to talk about that later today. And then Scott McCarthy is going to go deeper on containers. And he actually knows something about it. I'm just an imposter. So I really recommend that talk tomorrow morning. Other than that, I'll close with this outlining picture. And before you despair that because this is all fiction, unicorns are real. Thank you.
Okay, thank you for the great talk. We have a few minutes left for questions.
So are you running your mail server again, packaged as a Kubernetes operator?
So,
Please repeat.
I'm not doing, so the question was, will I run my own mail server again? So my goal is yes, I will run my own mail server again. Now, I think it's unrealistic for me to run my own mail server on my own. So I think what we need is a community model for operational excellence there. And maybe I can talk about that next year at FOSDEM. I have an idea. I actually shared it with you, Steph, once, 3 years ago. I have the domain, so I need to do the work.
Hi. Can you tell me a bit about the toolbox, which doesn't seem to be packaged yet? What does it do with the network namespace? Because that's where I've stubbed my toes with Kubernetes a lot. The V6 support is absent to hostile. And I can't run a mail server without V6.
Yeah. All right. So I think there are two questions in there. So one is like toolbox. I mentioned toolbox. So toolbox is not a Kubernetes thing. It's just an interactive container. The initial motivation is you're running an immutable host like CoreOS, or previously Atomic host, right, or whatever equivalent. You can't change the host, and you need an unprivileged user space to do whatever you want. So that's where Toolbox is good. But I use it on on this laptop. By the way, quick call out: if you're looking for good Linux laptop, Star Labs, awesome. It's a British company doing Linux optimized laptops, and I love them. Unfortunately, they're sold out right now because I want to get one for my daughter. But awesome. So. There was another company mentioned earlier. I always recommend Starlab. So I'm using it on a regular laptop, Toolbox, just interactively. Now the problem with Kubernetes and IPv6 is a problem. It's this thing like where it makes me despair that we have to recreate some problem over and over again because we don't learn. Hopefully it's going to get fixed now because there's a lot of demand because we really ran out of IP space this time. But Toolbox doesn't solve that problem.
Please excuse.
Well, yeah, you need IPv6. I 100% agree.
Gentlemen, thank you. Thank you a lot.
Thank you, everyone.